I'm going to talk today about IB Subtopics 2.1, 2.2, and 2.3, which is classifying data as discrete or continuous, generating frequency tables, and also making histograms. Let's talk about the difference between discrete and continuous real quick. Discrete variables are things you can count, and continuous, those are things you can measure. So the number of sweets in a packet, that's going to be discrete because you can count. The heights of students, that's something you can measure. Dress sizes of girls, sizes are, those are actually in sizes like 1, 2, 3, 4, 5, so those are discrete. You can't have a dress size of 13.247. The number of red cars in a parking lot, that's discrete, you can count that. The weights of kittens, that's continuous. The marks obtained by a grade 7 in a science test, that should theoretically be discrete or continuous, but we're going to say it's discrete because I'm going to assume that teacher doesn't assign a 70.32476. The times taken for students to write their world literature paper, time is continuous. Weights of apples is continuous. Number of centimeters of rain each day during the month of April. The amount of rain fallen, that's going to be continuous. Number of heads when a coin is tossed 60 times, that's discrete. The times taken for athletes to run a marathon, time is continuous. And the number of visitors to a blue mosque each day, we can count them, that is discrete. Next thing I want to talk about, since we've already talked about discrete and continuous, I want to talk about how to make a frequency table. So the number of goals scored by a football team during the last 25 games are right here. So we're going to have two columns. We're going to have number of goals, and we're going to have frequency, which I usually just write a lowercase f for that. So we've got 0, 1, 2, 3, 4, and 5. And then I like to total it out at the bottom here. So when we add it up, it should be 25. So we'll double check at the end and make sure we've done it correctly. The number of zeros, I've got 1, 2, 3, 4 zeros. The number of ones, 1, 2, 3, 4, 5, 6, 7 ones. Number of twos, 1, 2, 3, 4, 5, 6, 7 twos. Number of threes, 1, 2, 3, 4 threes. Number of fours, I see 1, 4. Number of fives, I see 1, 2, 5. So when I add those all up, 4 plus 7 is 11, plus 7 is 18, plus 4, 22, 23, 25 is the total, which is the number I'm supposed to get, and that's how you build a frequency table. Let's flip over here now. Sometimes you're given a frequency table and you're asked a question about it. So we're supposed to find the values of m and n. So this is simply asking us how many 8s are there, how many 10s are there. I see 1, 2, 3, 4, 5, 6 8s. How many 10s are there? 1, 2, 3, n equals 3 10s. When you're finding the lower and upper boundaries, you're simply taking averages. So for instance, the average of 12 and 13 is 12.5. Now this upper boundary is always going to be the same as this lower boundary. So I know that's 16.5, and that makes sense because halfway between 17 and 16, that's 16.5. Halfway between 20 and 21, that's 20.5. You might notice a pattern here. It's going down 4, it's going down 4. This better go down 4 as well. This should be 8.5. which makes sense if you think about taking the average of 8 and 9. It's 8.5. It's going up by 4, up by 4, up by 4, so you know this is 24.5. This is for discrete data. When it's continuous, it's much easier. It's just going to be 2.0, 2.2, 2.2, 2.4, 2.4, 2.6. That only works when the data is continuous, when you see these inequality signs like this. The last thing I want to talk about is building a histogram. In part A, it says write down the upper and lower boundaries for the third class. That's this one. Well, the upper boundary, the lower boundary is just 0.8. The upper boundary is 1. To draw a histogram, you always got to start with some labels. I usually put the frequency over here on the left. Down here we've got our mass in kilograms. And I like to start at 0. We'll go 0.4. Actually, we'll call that 0.2, 0.4, 0.6, 0.8. It's 1, 1.2, 1.4, 1.6. And then the frequency needs to go up to 34, so I think we can accomplish that just by going by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. So from 0.4 to 0.6, that goes all the way up to 21, which is halfway between 20 and 22. So that's the first part of our histogram right there. From 0.6 to 0.8, it's all the way up to 36. It's right up there. 0.8 to 1, it's all the way up to 34. From 1 to 1.2, it's 29, just halfway between 28 and 30. From 1.2 to 1.4, that's at 18. And then 1.4 to 1.6, that's at 12. So the big takeaways from this, make sure you label your axes with your units and put some numbers on there as well. Make sure you've got some scale. Also with histograms, there can be no space between the bars. If you put space between the bars, that's a bar chart, not a histogram. Bar charts are for categorical variables. Histograms are for quantitative variables. All right, that's it. Thanks for watching. We'll see you in the next one.